I've been exploring the belly of one of the most remarkable flying beasts. The rotor systems give it lift and stability. The collective, pedals, and cyclic work together to fly the machine. And that's not as easy as it looks. The helicopter is a complex machine that's hard to fly and takes precision to build. But how did it develop? For centuries, the helicopter stayed on the drawing board. Ever since the designs of Leonardo da Vinci 500 years ago, it's been a struggle to make the helicopter fly. By the 1940s, things were looking more promising, and the helicopter as we know it took shape. This is an early model of the Bell 47, the helicopter that took the world of aviation by storm. A veteran of the Korean War, more than 5,000 rolled off the production line. They had many uses, from mail delivery to cattle herding. Here at Fort Worth, they've got one of the early models. Only this is no museum piece. It actually flies. Now, this is basically one of the very first helicopters that the average man could fly, yeah?
This is the helicopter that got everything started in the world of helicopters.
The Bell 47 has an open cockpit, and all its component parts are exposed, including the engine. This is generally like a car engine.
Absolutely. It's got pistons and cylinders and valves and all that stuff, just like a car engine.
Okay. Locked in. Pump the gas like an old Chevy. Turn the key. Sounds more like a lawnmower than a helicopter. With no doors and a bubble cockpit, I feel really exposed up here. It feels like we're traveling at 100 miles per hour, and we're only going 40. But even at this low speed, Marty can throw the helicopter around the sky, using the controls to maneuver us any way he likes. The Bell 47 owes its agility to something that is key to all helicopter design. It lies at the base of the main rotor system. Nick Lapos is on hand to explain. What am I looking at?
Well, you're looking at the heart of the helicopter, the way the pilot controls it. This mechanism is called the swash plate.
Swash plate.
Swash plate.
Okay.
That's the principal control mechanism.
The pilot uses the collective and the cyclic to move the swash plate. Each control affects the angle of the rotor blades in a different way.
Suppose we wanted to raise the aircraft up.
Right.
All we do is raise the collective up. And notice both blades are moved simultaneously. See how much the blades dig in to move much more air. And by moving more air, the aircraft goes straight up.
What's amazing is that the levers from the swash plate adjust the rotor blades even while they're spinning at 300 times a minute. Okay, so that's how you go up and down. What about changing direction?
When the pilot moves the stick in the cockpit, he tilts the swash plate, and as he tilts this, then it sends signals up to the blades to change their angle.
So now the levers rise and fall as they go around. It means the blades can be adjusted to give more lift on one side of the aircraft than the other, allowing it to bank sideways or move forward or backward. And don't forget, this all happens in a split second. But like any complicated machine, things can and do go wrong. Mechanical failures and poor pilot judgment are catastrophic. In this case, the helicopter tried to fly with too many people on board, with disastrous consequences. Amazingly, there were no fatalities. And here, the pilot tries to take off, not realizing his tail rotor isn't working. But not all helicopter failures end in disaster. In my last flying lesson, I'm going to learn what to do when the engine fails mid-flight. I hope I don't get sick. Lynn Morgan, chief pilot, is going to take me through a procedure called auto-rotation. So now this auto rotation thing, this is literally, we're gonna be hundreds of feet in the air and you're gonna shut off the engine, correct?
That's what we're going to do.
So now, and what is the reason for learning this?
This is a single engine aircraft, and as reliable as its engines are, there's still going to be the time when the engine does fail. You need to be able to land that aircraft safely and confidently and not have any problems.
Here's the point of no return. I'm beginning to wish this show was about pickup trucks.
Auto rotation. This is going to be fun. You're going to like this.
I'll be honest, I'm a little nervous, the concept of being in the air and not having an engine, but I'm going to trust you. So, get me home safe.
And tower, we're setting up, coming in for landing. Roger.
I'm ready.
And the engine quit just like that. I'll lower the collective down.
Okay.
We fall at a stomach-churning 50 feet a second. With no engine power, the blades are now being driven just by the air rushing through them.
About 50 feet, I go into a nice decel. A little bit of cushion. And landing. Whoa! A little more round run than I thought, but not too bad.
Wow! I mean, that is amazing. All right, so now I noticed right there before we actually hit the ground, you really pulled up on the helicopter, kind of like that went straight up. What's the reason for that?
At about 50 feet off the ground, I brought the nose up, and that brings the rotor up into the airstream. It helps brake it and slow the aircraft down, and then you touch down gently.
Now, what would have happened if you would have not done that?
If you don't do that, you fall pretty rapid.
Like a rock.
Yeah.
Hi, I'm Rossi Morielli, and I'm getting to know this beast, the helicopter, inside and out. Now that I've had my first flying lesson, it's time to take things to the next level. What happens when you put the strength, maneuverability, and stability of this machine to work? I'm at the Los Angeles County Fire Department to find out. Their choppers are a vital weapon against forest fires, but that's not all they do.
Helicopters are multi-mission machines, but one of the most important missions they have is saving lives.
With over 2,000 call-outs a year, these guys are used to life-saving. 9 helicopters patrol 4,000 square miles of the county, and they have to be trained and ready to deal with anything.
So right now, I'm on a point in the middle of nowhere. I can't get out, I'm injured. Helicopters fly in where nobody else can get to. Send the guy down and get me out of here.
I got 80 feet of cable out.
These guys do 40 hoist missions a year. Now it's my turn to find out how it's done.
5, 4, tail's clear.
Paramedic Joe Coffey comes to my rescue.
How you doing?
PJ, how you doing?
I'm good.
My passport out of here is the so-called screamer suit. Now, I wonder how it got its name.
Right back, do not grab the hook itself.
Okay.
Okay? Hang on to your carabiner. That's your life support. And just enjoy the ride up.
Okay, he's got the hook. Hold right there.
Enjoy your ride!
This is called a hoist. It's the most dangerous thing that a helicopter can do because they've got to hover at the same time while pulling me up and keeping me safe.
It's what helicopters are uniquely suited for, but hovering at maximum power at low altitude is when the aircraft is most vulnerable. If engines fail at a 1,000-foot hover, there's time for the pilot to use auto rotation to descend safely. And at a low hover of, say, 15 feet, you'd probably survive an emergency landing. But at hoist height, that's 1 to 200 feet. There's not enough rotor speed, altitude, or time to get the chopper out of trouble.
Okay, coming on in.
Rescues are often made dangerous by wind, rain, and the terrain, like cliffs and canyons.
Okay, I got him right here. Job well done. Pretty impressive.
Fred Chavez is the hoist operator.
Okay, I'm disarmed and cabin is secure. Fred, I want to ask you back there, how important is the communication between you and the pilot?
The communication is absolutely essential. I'm his eyes and ears. We have a lot of hikers that get lost in tight canyons or fall off waterfalls. So your rotor clearance is very, very important. If we ever smack a rotor, it's the end of our day, it's the end of our lives.
So having a lookout is vital. If a blade is clipped, the pilot loses all control. This news helicopter hit its rotor on a building in Brooklyn. All 3 passengers were lucky to survive. We head back to base where I link up with the ground crew. Working a helicopter hard puts huge stresses on the moving parts. And that means one heck of a maintenance schedule.
Andy, how we doing up there?
Yeah, yourself?
Andy Young has been working with helicopters for 15 years.
What do you have the most trouble with? What's the most difficult to keep up to date and keep up?
Yeah, leaks.
Leaks? Really?
Everything leaks.
Really?
There's so much stress on every component in these aircraft.
For every hour this Bell 412 is in the air, it gets 5 hours of upkeep. So helicopters are maintenance intensive. And this giant is no exception. The Erickson S-64 air crane is a firefighter of the first order. Maintenance engineer Duke knows this beast inside and out.
How big is that tail rotor?
16 feet in diameter.
I mean, these things are monsters. Duke, tell me this. What is your favorite part about this thing? I mean, because you obviously love it. You know everything about it, and you smile big while you talk about it.
No, I do.
What is it? What is your favorite part about this helicopter?
I guess it's strength.
Really?
It's power.
The helicopter weighs a colossal 20,000 pounds and has the ability to lift a payload equal to its own weight. No wonder the main rotors measure 72 feet tip to tip. Lift isn't just about the rotor system, it's about power. And this beast of a helicopter has one of the biggest power packs of all. In fact, it's 2 massive Pratt & Whitney turboshaft engines that power this giant. It can drop 2,000 gallons of water in one pass. And it has a super efficient way of collecting water, the sea snorkel. It does this at speeds of 40 miles per hour. When the tanks are full, the arm is retracted and off it goes to fight the fire. The water it carries is so heavy, if it was dropped on a car, it would flatten it.